everybody, and welcome today. Josh and I are here with the Cloud Security Alliance and the Zero Trust 4-pillar working group to let you know about some guidance we recently put out and published just a couple weeks ago, Josh, I guess at this point.
That's right.
The Cloud Security Alliance wanted to offer to the community guidance for critical infrastructure, and we started with this document that was specifically tailored for operational technology and industrial control environments and how to apply zero trust to those environments because they're a little bit different than what we do on the IT side. So this has been a labor of love and a joint effort with Josh and I, both as co-leads on the paper as primary authors, but then a long list of other contributors who have just given an amazing amount of time, effort, and great content to this document. So we're going to talk a little bit about what's in that document, and hopefully along the way, just educate you as to, if you're not going to read the document, you'll get a little bit of knowledge about what we're thinking about and how we think you can apply these principles. But we definitely think that this document is a great resource. It's free to download. So Josh, let's get started talking about, can you talk us through the 5 steps of the Zero Trust Roadmap?
Absolutely. Yeah. Thank you, JJ. What a great intro. I do want to make sure we give credit where credit's due. We had a lot of industry experts, quite a long public peer review period. So JJ kind of said it. I'll say it again. We really think this document's amazing. We think it's highly educational. So we encourage everyone to download this and take a read. I know I learned a lot putting this together, working with JJ and the Cloud Security Alliance Zero Trust Working Group. So there is a 5-step zero trust implementation process that was really articulated by John Kindervag way back in the NSTAC report that the CSA embraces and likes to espouse as the right way to go about implementing zero trust. So a lot of our guidance papers within Cloud Security Alliance, they'll use that 5-step process. And we walk OT through the 5-step process. This is the first of its kind. I'll say there really isn't a lot of prescriptive guidance to how you go about applying zero trust to operational technology and critical infrastructure. That's what we're really trying to do here. It's really one of the main themes we're trying to get across is zero trust does work in OT. There are some high-level papers, conceptual, some great papers out there, but none of them really walk you through the process. And that's why we've mapped these 5 steps here. So the 5-step implementation process, as espoused by Cloud Security Alliance, the very first thing is define your protect surface. And I think even starting that out as the very first thing you do implies the difference with zero trust. You're here at the Zero Trust Summit. I'm assuming we already know what zero trust means, the definition. There's quite a few, but we've settled on one. But one of the biggest differences with the identity-based security model that is zero trust is you invert your attack surface to protect surfaces, and you do those one at a time. It's the first step of the 5 steps. So defining your protect surface is really what are your assets? In OT, it's your asset register. Could be a spreadsheet, could be a hand-drawn card, whatever you're using. But those protect surfaces are things you want to assess criticality on, and that's really the order in application of the zero trust process in OT. And it's interesting, we talk about this in the paper, but while the first step is define the protect surface, and that's you generally try to do as much of your asset inventory as you can, steps 2 through 5 are really repetitive. So step 2, you want to map the transaction flows, and in operational technology, we call it map the operational flows, because transactions are a little less relevant in OT. In OT, it's operational flows we felt was the right vernacular. So we talk about mapping the operational flows as step 2. Step 3 is design the zero trust architecture. Where are you going to place enforcement points in your policy engine, otherwise known as PEPs and PDPs? Step 4 is define your policy itself that you plug into that architecture. And the 5th step is really monitor and maintain, and really a rinse and repeat. So you do step 1, kind of get your list of assets, and then you do steps 2 through 5 over and over again.
Yeah.
So we talked about that, but what do you think about that, JJ? You think this is applicable to an OT environment?
Yeah, and I think there's OT and ICS is just it's multifaceted and in many cases, different from IT, which we'll talk about in a second. But as it relates to the five steps, what we wanted to do is not, make this guidance be very pie in the sky, some, crazy ideal way of doing things that was just not attainable for the bulk of the environments and the organizations and the professionals out there. So, when we talk about defining the protect surface, which is really just asset inventory, yeah, I mean, Josh, you said it. Sometimes they're on sticky notes or pieces of paper or a worksheet, and that's okay if that's what you have to start with. So what we do is kind of outline where you might be starting, meet you where you are in that, and then make some suggestions about ways to make that more dynamic and automated and integrated if you can do that. And kind of working through the maturity of what that process looks like, in that case for asset inventory. And then as we get down in the other steps, the same things, right? We don't necessarily have the same processes and tools on the OT side that we have in IT. So we have to adjust. We can apply zero trust. We just can't, the concept is the same, but the application of it and operationalizing it is very different. And so each of these steps is very tailored for OT, and it's very specific. We talk about when you get into building a zero trust architecture, where can you position those policy enforcement points or those monitoring areas so that we can funnel traffic to get very high fidelity reporting in the OT environment. We talk about different ways to segment. We our normal things we do in IT, we've got, access control lists at layer 3, we've got VLAN constructs at layer 2, you've got physical segmentation and, the I'm going to air quote air gap that doesn't really exist anywhere. But then we have other tools in OT that might be applicable. We do talk about, some of the more ZTNA, zero trust, software-based implementations where if you can do something at layer 7 higher up the OSI stack, that's fantastic. But we realize that in OT, you may not be able to do that. And so then how do we adjust down and start using, I'm going to use, lower stacks in the OSI model. How can we use the network that's there? Or if we need to upfit the network to do something a little bit different. So all of these things are, we talk about data diodes, we talk about cross-domain solutions so that you have something that you can actually do in an OT environment. And I think that's really what makes me so happy here. When we set out with this, we really wanted something that you guys could operationalize, not just this is the way that the ideal, target would be, but we don't really have a path to get there and it's just not achievable.
And I love this paper because there are so many guidance documents for zero trust in general for IT. And it's been an absolute pleasure working with JJ and all the other contributors here because it really does apply to OT, and this paper describes how. And I think even the first half is just really talking about differences between OT and IT. I think we take great care and time in explaining those differences, both in the objectives, in the technologies, and we even talk about even different threat vectors. That's kind of another key point. So we start off acknowledging and really educating folks on IT is this, OT is that. Let's first get this out of the way. Let's first talk about all those differences, and really OT being reliability and safety are paramount, right? In IT, it might be the CIA triad. In OT, it might be the AA triad, availability as a joke. But I think safety and reliability and resiliency trumps all because there are human lives at stake oftentimes, or at least the well-being of human civilization. I mean, no pressure. So I love how we level set, talk about the differences, why it's different. And then JJ, to your point, we really start going into great. Now that we've defined these differences, how do you go about applying zero trust in that different environment? In our agenda here that we've kind of thrown up 6 key points that you'll see flash on and off throughout the presentation. They really do follow the document. So we start with this 5-step zero trust implementation process we've just talked about. The paper goes deeper into differences between OT and IT, and perhaps we could talk about a few more here in both objectives and technology. I think convergence of OT with IT is a big theme. It's a big challenge within OT and industrial control systems. So we spend a bit of time defining that, and we'll talk about it here, unique challenges. And then really the bulk of the paper is focused on mapping the zero trust 5-step, but also comparing it to existing guidance that is out there today, the ISA, IEC 62443, the zones and conduit model, as well as SANS top 5 critical controls.
Yeah. And there's
And
some
then
NIST, I think there's some NIST cross references in there as well, because we've got good guidance there.
JJ, I don't know if everybody's going to read the 3 pages of references that we put in the back, but we literally have 3 pages of references because we wanted this to be a very all-inclusive guide from which you can springboard off further research, investigate different papers from CISA to Department of Defense to Dragos and all other different very valuable resources. So yes, there's much more to read. We're going to try to cover the high level here.
Well, let's talk about a little bit about the differences between OT and IT, because I think this is important and it's something that we hear a lot. Well, okay, I hear 2 conflicting things, depending on who's trying to sell you something. You know, one thing we tend to hear is OT is not like IT. We've got to treat it differently. I live in that camp, having worked in different critical infrastructure environments for about 2 decades. You know, that's how I feel. And I think let's talk about that in a second. But then the other camp will tell you we can do the same things. And I think what they really mean to say is we can apply the same concepts, just like we're telling you this with zero trust. But again, how we execute against that, the tools that we use, our workflows and processes might need to look a little bit different, because at the end of the day, the culture of operational technology and enterprise IT is just different. We're trying to do different things for different reasons. And it's hard to reconcile that, especially if you're coming from the IT side, or you've worked in security and security architecture, or like a SOC as an analyst from the IT side, because we don't have the same processes, policies, et cetera. You know, one of the things, for example, you know, I think we cite this in the paper, you know, you don't want to lock an OT operator out of an HMI in the middle of an issue, right? You don't want them to have something crazy is happening over here. Maybe there's an alarm, this, that, or the other. You don't want that operator, that engineer, locked out of anything because they fumbled or mistyped a password a couple of times. That's just not appropriate. And patching. Josh, I think what was, you know, some of the reports from different places we pulled, Dragos, Clarity, Armis, companies like that, it was less than 10% of the time that patching was the right answer.
It's amazing. Yeah. So what do you do? Right? How do you go about doing it? Well, you have to mitigate in other ways. I think that was a real eye opener for me as well, JJ. The how different you have to think about applying security. And I love the lockout example because it's such a common security control in IT, right? You miss your password, you mistype, you don't do the MFA right, well, you're locked out. You know, submit a help desk ticket. I think another thing in the paper that's quite intriguing, describing even as you're defining the protect surface and you're going through those 5 steps, understanding relativity and criticality within the business. While it might be a cheap little part, I think we use an example in the paper about it in a pharmaceutical example, a $1,500 logic controller. If you're not protecting that, it gets compromised. It could impact, you know, tens of millions of dollars of production or even availability of a drug to people who need it. So it's these kind of things are not typical things you deal with in IT. So we do, I think, a pretty good job of articulating those differences and how you could still go about applying a zero trust model, but how it's different. The difference is big. So we spend a lot of time in that.
It is.
And it's very eye-opening.
We're also converging these 2 infrastructures as well, which is also confusing because we're saying, you know, they're different, they're separate, segment. But the reality is that we have to deal with, we are in some ways integrating and converging OT and IT to varying degrees and in varying ways. But there's this not just security component, but there's always a security component, but there's also a resilience component, you know, Josh, just like you're saying, whether it's manufacturing, it's doing critical manufacturing, and you have, other people and other supply chains relying on you to deliver what you're doing that impacts, the community or the population, the world. Similarly, just being, a little bit more commercial in this. What is the word I'm looking for? Some companies are out there to make money, and it is very impactful if we don't have these things segmented properly and secured properly, because an outage, sometimes of a part that's less than $100, can impact a manufacturing line in the tunes of thousands, tens of thousands, sometimes millions of dollars an hour or a day. And that's definitely a consideration, because this type of architecture really is one of those, feed three birds with one scone sort of things, where we can do one thing and we can get several benefits from it.
It's fascinating. I think what's the term I see used in the space? High impact, low frequency cyber infrastructure attacks.
Yeah.
They may not happen as often, but when they do, man, can have a cascading impact. And that's such a good point, JJ. Even as we're doing the paper, it was something I hadn't thought about how the critical infrastructure sectors, even within and amongst them, there's dependencies. Like an energy plant needs water.
Yeah.
Of course they do. So think about those cascading impacts, and just it really elevates the criticality of applying a very tailored, effective security controls. And I really don't think there's a better way to do that than with zero trust.
Yeah. And I like food, right? Agriculture, you need transportation to get the food to me for me to eat it. Like everything is so interdependent these days. I'm laughing. But I think the point is like we think of, well, a lot of, I think people think of, when we say critical infrastructure, they think, well, that's not me. That's power, generation, distribution, that's water, that's utilities, it's gas, oil. But the truth is, we covered this, Josh. Now, you guys, even just getting everybody to agree on what qualified as, I'm air quoting, critical infrastructure was its own undertaking. So, throughout the world, there's a 10 or 12 common, industries that are identified pretty consistently across all regions. Here in the US, CISA has identified 16, but it's basically anything that impacts the public. So it's everything from healthcare to agriculture and food to retail to government offices to large public venues and entertainment, in addition to all of the stuff that we tend to think of as critical infrastructure. And it is all so connected. I mean, we've seen examples after this, time and time again with, Colonial Pipeline and Maersk and Merck and, dealing with things like NotPetya a few years ago.
Right. Or even the power plant in North Carolina got shot by a rifle. And I mean, how many thousands of people were without power? Talk about some unique aspects of things you just don't think about. It's like a dial tone, right? It's like, well, of course, when actually, I'm aging myself. Who even knows what a dial tone is anymore? But remember when you used to pick up the phone and there would be a dial tone?
Yeah.
And it would just always work.
Hey, look, I remember the rotary phones and dialing with the end of a pencil. Like that, I just definitely gave away my age. I shouldn't have done that. But yeah, no, I was there.
I did a test with my nephew. I gave him a rotary phone. I said, what do you do with this? He couldn't figure it out. Anyway, that's a side topic of aging ourselves. I like the way Rob Lee put it from Dragos. OT is IT with physics, right? This quote he made, I really love it. It is more prevalent than you think. It's all around us. I think we often take it for granted, but it's high impact. So this is really critical guidance. But I think to your point, JJ, the whole convergence is it's inevitable. I mean, to your point about commercial viability, these companies aren't, they have to make money. They have to provide services or products that are of value. And in order to do that, they need to innovate and they need to embrace digital transformation. And they want to use the cloud. They want to use real-time, just-in-time manufacturing, or they want to get all of the sensors from a locomotive for predictive analytics. Like there's a lot of data. There's a lot of technology out there that can be leveraged to make your OT or ICS more effective. And this convergence is happening whether we like it or not. So I think we do spend quite a bit of time on that. And again, JJ, what's the biggest surprise to you? I was quite surprised, but for you, a convergence or a surprise or have you found something out there that this paper really speaks to? You're like, don't do this, guys, or be aware of that.
Being a security architect for a long time, I'm kind of the mindset that there are very few times to use the words always and never. And again, I try to give a lot of grace because, with what I've done is, my role and my job for a long time has been working with different customers in each of these, sectors very, very closely and very deeply. So I get to see a lot of different environments and a lot of different, cultures and what they're doing. And just to have a lot of grace and not judge where somebody is in this. So, it's hard to shock me when it comes to these things because I've seen some seen some crazy stuff. But at the end of the day, everybody's just trying to, do the best they can do with what they have. And sometimes they just don't know, which is why I thought this paper was fantastic for the Cloud Security Alliance to pursue. And it's just one in a series that they're going to be doing, and IoT stuff as well. I did want to throw out there, though, because you're talking about, digital transformation and convergence. And, there are, so a couple things in the paper. We do present the Purdue model. And, don't yell and don't cuss about that. Just there, it's really just meant as a conversation starter. The way that we have personality tests at work, right? It's not meant to put things in buckets and make something rigid. It's just to open up the conversation and understand somebody else's language in their world and how and why they're responding to things. Our use of the Purdue model, because we think the primary audience for this guide is going to be IT and security professionals that came from the IT side who have been tasked with securing OT in different ways, sometimes by policy, sometimes by, tooling and controls, monitoring, incident response, et cetera. So we wanted to do is just give that other population a glimpse of kind of the cookie cutter idea, enough that they can point to different things, like, data historians, the various, remote accesses and jump servers that might be existent, the HMIs and the various, types of servers and services and directories, getting down into then, the lower levels of the Purdue model where the actual kind of assets are. It's really just meant as a conversation starter. It's a good visual. The truth is, most organizations, because Josh, I'm answering your question in a very, very roundabout way. Most organizations don't look like that. It's not that pretty. It's not that clear cut. Yeah. It's sometimes one big flat jumbled network, even between sites. And so again, this is we're trying to not force you into some perfect state in the future. We're trying to figure out where you are and then give you some incremental steps to at least make yourself more secure and more resilient with what you have. But yeah, I mean, you've got business systems, manufacturing systems. Typically we see things going out from the OT environment into something else, right? Unidirectionally, where we're pushing that up into something in the enterprise IT, like billing, or up into the cloud for analysis. I think where we get a little twitchy still, because again, the Purdue model is meant for a conversation starter. It's not meant as security architecture, but it certainly doesn't deal with, or the original one doesn't deal with these other digital transformation connections and these integrations that we have. So, a few different organizations have come up with some. I think it's great to go explore those. We probably linked to some in the references. Sorry, Josh, what were you going to say there?
No, I love that you brought that up. And I do have some critical infrastructure companies I work with, and the Purdue model, just understanding that, and that's why we introduced it in the paper. It gives you a way to reason about the problem that you're dealing with. And sure, maybe it's not that pretty and all clear cut, but you talk about the process control zone. You're at layers or level 0 of the Purdue model. Oh, great. That's probably flat network. How do you put choke points in there? How do you narrow that down to smaller protect surfaces so that you can apply more tailored controls? We go into a great detail in the document about that. Some really great ideas for leveraging the OSI network model, mapping to the Purdue levels and saying, great, it's probably a level 3, routing control that you want to apply to a flat network where it's industrial protocols and you don't have IP everywhere. So can you put something in front of it to create a choke point or a policy enforcement point? I love how we talk about that in the paper. There's some great nuggets in there. I think everybody could get some value out of because it really does cross that divide of IT to OT. How do you provide a security control? Just there are and the unique challenges of doing that. But I think the other thing too about the Purdue model, JJ, the ISA IEC 62443 set of standards, which critical infrastructure folks are probably very familiar with in operational technology, they also use the Purdue model to shape their language, and they break things down into zones and conduits, and you can have different zones at different levels with conduits that connect you to other zones. We map that into language within the paper about protect surfaces, and we try to break down a protect surface from, in IT, we'll often call it a business information system. And we'll break that down into the individual components, such as DAS elements is a term that's used, DAAS, data, applications, assets, and services. Those don't translate perfectly well to an OT environment, but we do describe some, well, you could do zones and conduits. You could break those down further into operational systems. In some cases, if you're able to break those further down into individual assets, at least in a way that can allow you to implement a more tailored, a more precise control for fine-grained, least privilege access to one of the most critical things you're trying to protect. There's no hard and fast thing. I think that's another thing we say, especially throughout and in the end, is we're not trying to give hard and fast guidance. This is for you to mold and shape into what works for you, because every environment's unique. And that's not just IT, that's OT, especially with all the legacy and age of the equipment. So it's a lot of thoughts and a lot of approaches that use that Purdue model. So I do think it's a great reference architecture just to allow folks to speak a common language. So I'm thankful for it for that.
Yeah. And it does loosely relate to the capabilities of the devices or systems at each level, because as you get further up in the numbering and just, we do make the distinction that we do talk about the OSI layers at one point, right? Up through 7. And then there are the Purdue levels, which is a different construct. Right. But as you get up into closer to where that border with the enterprise IT system is, those are typically, more capable in the way that, a lot of those things in the middle of the Purdue model are running Windows. Maybe not a full normal version of Windows, maybe an old version. It's, limited by one of the manufacturers that's managing some of the infrastructure for you, purpose built for what they want it to do. And then as you get down, then you start getting into the things that are doing, Profibus and Modbus and all of the other protocols that might be happening. So what we can do, and I actually forgot earlier this year, I made like a Purdue model family view, which is kind of like has the babies down at the bottom.
It's really good.
And actually, I forgot about that until right now, actually. But it was out of a conversation with somebody. But it's the same construct within the networking tools of what we can do down here at levels 1 and 2 in Purdue. We don't necessarily do the same thing that we do up at like 3 and coming into the border with the IT side. So yeah, ISA had, their 99 group had a model that's basically what, I don't know which came first, but Purdue or that. Same kind of construct. And then we looked at this, asset inventory transaction or operation flow mapping, and it looked a lot like what the ISA 62443 set of standards already had mapped out in zones and conduits. So why would we reinvent the wheel, right? And give everybody something different but similar when there's already something there that you're probably familiar with. It very well developed set of standards, internationally. Contributed to, a lot like the Cloud Security Alliance does stuff. So throughout the document, I think we've found great crossovers like this where we don't need to reinvent the wheel. We can take the language from the Cloud Security Alliance Zero Trust Roadmap, and we can align that with these other standards that are out there.
There are actually, even in our references, I think we give 3 or 4 different guides of mapping 62443 to Zero Trust, and because it's a nice complementary set of reference architectures. the difference with this is we actually get a little bit more, we provide more prescriptive guidance, and not prescriptive hard and fast, but more tactical, like things that you can do now, and how can you actually implement things to enforce policy within this construct. And so I guess I'm touting our paper, but I couldn't find guidance like this out there. There's a lot of guidance out that maps some of the standards to zero trust at that conceptual level. But I would encourage all of you to read this paper to get more practical, tactical, like, well, what does this actually mean to me? Because I think we do a great job in the paper of that.
Yeah.
And I know, being mindful of time, JJ, I know there was one point that I thought was worth calling out, and we put it here on our slide, on our agenda. It was the 6th agenda item, but it's stitched throughout the paper. The importance of connecting with an OT specific incident response firm that specializes in OT and critical infrastructure, industrial control systems, because they're different when you got to respond and safety is at stake and human lives are at stake. And also not just finding an OT specific incident response firm, but doing that before an incident actually happens. I think it's such key guidance. I wanted to mention it here. What do you think of the criticality of this, JJ? I mean,
wildly critical, and I'm really glad you pulled this up, Josh, because I mean, this is the drum I think we all beat in this space, which is your enterprise IT team internally or your external consultant that you might be using. If they are IT specific, if they are not OT specific and dedicated to operational technology environments, they're not the right people to be responding. That's, again, internal or external, doesn't matter. You're talking about, a level of understanding these systems deeply in order to do forensic analysis to preserve what you need without impacting the system further. And I can't stress enough, if you take nothing else away from this and you never read the paper, at least remember this, because if you have these environments and they're your responsibility now, the one thing that you will think your future self will thank your current self for later is to identify a partner. And Josh, I know we don't tend to like to mention a lot of vendors and Cloud Security Alliance papers simply because we don't want to be showing, favoritism or anything. However, when you're dealing with new spaces and new territory, you will notice a lot of vendors mentioned throughout this paper because we wanted to give you context of some of the organizations that are known. Now, this is a growing space, and there's lots of vendors and solutions popping up. And I'm sure somebody's Google ads for the competitors will pop up when you go Google the companies and the solutions, but it's a starting point. But you do have to engage these organizations before the incident. You can't call you can't call them in the middle of the night when everything's on fire and nothing's working. You need to have that relationship and those processes ahead of time. And that's so critical, Josh.
By the way, I'll make a plug for JJ's podcast, Packet Protector. She recently had Mike Holcomb on there, ICS/OT expert, and talking about how he can count on one hand the number of companies that specializes that he would trust. They're important. I think just the sheer specialization is enough to make the point that, it matters. You really do need somebody that knows what they're doing in the space. Like a safety instrumented system is there for a reason. Like, you should probably work around that when you're trying to shut things down, or at least make sure you understand what doing something over here is going to do over there, primarily around human safety and hopefully keeping operations running.
Now, we've been talking about the document, so I think we should tell them how to find this wonderful, fantastic document. If you look at the Cloud Security Alliance site and you look for Zero Trust guidance for critical infrastructure, you can probably just Google that and it will pop up. That's how I keep finding it. But Josh has a link for you guys here as well. Yes.
So please, we encourage you to read it. It's a bit on the longer side compared to some of our other guidance in Cloud Security Alliance, but it's with great care. As JJ said, it's a labor of love. I think it's full of great information, full of great guidance, and we love your feedback. We'd also love to hear from you guys. Our next paper, as JJ mentioned, we're focusing on IoT specifically. We're also looking into some other device specific research, endpoint research, and how you go about applying zero trust to that. But we're always open to feedback and input. But for now, check this paper out and let us know what you think.